Well, those of you joining on YouTube, I did the first two problems. Sorry about that. I will keep explaining the second one. Set it all up and I didn't. Welcome back. Okay. We were combining these parts, we were combining like terms, we were combining these functions. So 2x minus 3x is negative x minus 1. And again, that's as simple as that one gets. What's my domain here? All rails. Yeah, negative infinity, positive infinity. Again, unless it's the denominator and unless it's a radical, we don't, it's all real numbers. Those are the only ones that we're worried about. All right, now we're going to multiply these two functions together. So I'm going to multiply 3x plus 2 times g of x, which is x squared minus 1. That little dot in between them means multiply. So we are going to multiply, and do not forget to FOIL all the way out. So I'm going to multiply all of these pieces together. 3x times x squared is 3x to the third. 3x times negative 1 is minus 3x. 2 times x squared is 2x squared, and then 2 times negative 1 is minus 2. Now I'm going to put this in the correct order. There's no things to combine here, but I can reorder it so it's best. 3x to the third plus 2x squared minus 3x minus 2. What's my domain here? All reals again? Yep. We doing okay so far? Okay, the next one says hx times px. So again, we're going to multiply them together. Hx was this 2x, and then px we haven't even looked at yet. That's square root of x. So we're going to do 2x times square root of x. And I cannot combine that anymore to like be a smaller thing or get better, like easier things multiplied together. So we can just leave it 2x square root of x. Now my domain here though, I have this radical. What did we say was the issue with the radical? What do we only want? What can we only plug into radicals? Positive numbers, so greater than or equal to 0. So x has to be greater than or equal to 0. That is part of my domain. That's the only restraint, the only constriction I have on my domain. So my domain here is going to be 0 to positive infinity. This time I can't put in negative numbers because I can't do the square root of a negative number. That would give me an imaginary number, not a real number. So we can't have that. And then now my last one here is going to be h divided by f. So h was that 2x and then f was 3x plus 2. So 2x over 3x plus 2. Can I combine or cancel anything here? I'm always tempted to do it with the x's, right? Once we have these x's, sometimes we're like, oh, you can take the x out. You can't do it unless we have an x over there as well. So there needs to be an x in every single part in order for us to take an x out. So this actually is as simple as it gets. However, I do have something to worry about here. I cannot have my denominator equal what? My denominator cannot equal what? 0. So that is what I'm worried about. That is not part of my domain. So I say 3x plus 2 cannot equal 0. So 3x cannot equal negative 2. And x cannot equal negative 2/3. Okay. Now, when I write my domain, though, we never just leave it like that. We have to write it in interval notation. So we can do literally any number but negative 2/3. I can go negative infinity to negative 2/3 with a parentheses, and then union negative 2/3 to positive infinity.
If you're finding the horizontal asymptote on that, would it be 2 or 3?
That would be my vertical asymptote. Yep. Which I didn't look at your guys' quizzes hard enough to see that, but I know my other class kept mixing those up. So remember, your vertical asymptote is your denominator when it equals 0. So what is not part of your domain is the same thing as what your vertical asymptote is. Does anyone know what my horizontal asymptote of this example would be? 2/3. Very good. Y equals 2/3. How'd you get that? What did you look at?
Divide the coefficient.
The coefficients, very good. So I have an X on top, I have an X on bottom, so I'm able to know that their exponents are the same. So go look at the coefficients, and that is what my job is there. All right, we're just gonna do a couple more. These are all compositions right here. When we do compositions, we are putting one function in another function. Essentially, we're taking one function and putting it into the other function at X. Does composition sound like something you've done before? Yeah, okay. Could also go over it slowly, but I'm hoping it's something that we've seen before. So this first one says P of H of 1. So I have P is my outside function. That means H is gonna go inside of P. So H is inside of that bracket, so H is gonna go inside of P. So let's go find P first. And we're gonna write it, so P is root X. Okay, square root of X. Now, the point of the composition is instead of writing X, we're gonna write the function of H. So I'm gonna erase that X, oh, that's too much erasing. I'm gonna erase that X and I'm gonna put H on the inside. So function H was 2X, so I'm gonna put 2X where the X was for my P. Now, it doesn't say P of H of X, it says P of H of 1. So instead of X, what am I gonna write?
1.
1. And so that means I can erase that X and I can write a 1. Now, you can do this a couple different ways. If you were like, that was a lot of erasing and I'm not really sure what's what, you can do H of 1 first. So you can take H, which was 2X, and make it 2 times 1 first, and then put that inside of P. Or you can again build it from the outside. So I had P was the outside, then inside of that I put H, then inside of that I put 1. And so when you do that, 2 times 1 is gonna be 2, and it just stays under that radical. So it's gonna be square root of 2, and I can't simplify that anymore. The next one says H of F of 2, which function's on my inside this time? Not H. H is on it's first, so it's gonna go on the outside. What's second? F. F is gonna be on the inside, which means that H is on the outside. So let's do H first. So it's 2X. So instead of saying 2X, we're gonna say 2 of something. And that something is gonna be my F function. And my F function is 3X plus 2. So inside where there was X, I'm gonna put 3X plus 2. However, it says H of F of 2, so instead of X, what am I gonna write? 2. Okay, then we simplify. I've got 2 times 6 plus 2, which is gonna be 2 times 8, which is going to be 16. Whenever we're doing like a composition with a number instead of with X, so this one was of 1, this one was of 2, your final answer is just a number. The next one says H of F of X, that's gonna be a whole expression. We should still have X's left in that one. This time, again, it's written like the first one, so H is my outside function, F is my inside function, and then I've got nothing to plug in for X. I'm just gonna put F inside of H. So actually we just kind of did that, didn't we? 2X was my H, and instead of X, I'm gonna go ahead and put F. So I'm gonna do 3X plus 2. Since it says we're doing that of F of X, I'm not putting any number in for X, I'm just gonna leave it. However, we can distribute, bless you, that 2 in order to make it more simple. So it becomes 6X plus 4. Okay. If you've noticed on the last couple, we've had different notation each time. The last one says FG. It doesn't say F of G of X. It doesn't say F of G of X. It just says FG. That is not a composition. That's a multiplication problem. So we try to trick you right here by showing you a multiplication problem. This is another way to do multiplication. It is not a way to do a composition. And I actually think we did this one earlier. Didn't we do F times G earlier? Yeah, we did it up here at C. We did F times G up there. So like you could look at like number 1 letter C in order to see what that looks like. I just wanted to get a little brief bit into this part. Maybe I'll have some more practice with these kind of compositions and adding and subtracting functions on Monday or on Tuesday, okay? We're gonna finish 1-4, do some practice, review, and then test next week. I don't think I see you on Friday, so that's all that is.